D block elements, F block elements. இந்த ரெண்டு பிளாக்லையும் இந்த ஸ்கிரீனிங் எஃபெக்ட் அதாவது ஷீல்டிங் எஃபெக்ட் எப்படி ஒர்க் அவுட் ஆக போகுது அப்படிங்கறத நம்ம டிஸ்கஸ் பண்ண போறோம். Now let us talk about the D block elements. As we move across a transition series from scandium to zinc, electrons are added to the inner, that is n minus 1 D subshell. Nth subshell can be called ultimate shell. Nth level can be called ultimate shell. And the n minus 1th shell can be called penultimate shell. It means if I got fourth shell, what is penultimate shell? Third shell. That's all. N minus 1, 4 minus 1. And here it is given as transition series from scandium to zinc. In fact, I suggest my students to memorize at least the first row of D block elements like Scatti Vikraman and Feconi cousin. That is scandium, titanium, vanadium, chromium, manganese. Starting from 20, 21, 22, 23, sorry, 21, 22, 23, 24, 25. 21, 22, 23, 24, 25. These are the numbers, atomic numbers. And Feconi cousin, 26, 27, 28, 29, 30. So it means from scandium to zinc, the electrons are being added in the D shell. What about the D orbital? So here you have dxy, dyz, dxz, dx squared minus y squared, and dz squared. So here it is being filled up one by one. So we have all these electron numbers getting filled up. So for every addition of these electron, we expect an increase in the effective nuclear charge, right? Now let us see. As we move across transition series from scandium to zinc, that is from scandium to zinc, electrons are added in the n minus 1 d subshell. It means what? For example, it is added in the 3D level because 4s2 is here. So this is nth level and this is n minus 1th orbital. Okay, right. So in the n minus 1 subshell, I hope now you should be able to understand this. Then while the outermost shell means nth shell, remains almost the same, which is nothing but ns2. Don't call it ns squared, it is ns2. So the ns2 remains almost same. This is a very important point. Whereas the electrons are added in the inner shell. It means 4s2 is kept constant and we are adding one by one. I will explain with the electronic configuration so that you can understand better. Now, let me take up this, that is titanium and iron. Okay. What is the atomic number of titanium here? Scatti Vikraman 21, 22. Is it not? So this is titanium 22. We are going on increasing. Now we are here iron 26. Let us analyze the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, and immediately 4s2 is written here and that remains constant. Then we add up the remaining. So here 2 plus 2, 4, 10, 12, 18, 20. Then we can take 3D2. Or you will follow. So this is the nth shell. This is the n minus 1th shell. Ultimate shell, penultimate shell. Now let us talk about the ion. 1s2, 2s2, 2p6, 3s2, 3p6, and now 4s2. It remains constant, right? Nth level. But here that is 2, 4, 10, and then 18, 20. So here 3D6. So this varies, is it not? In this case 3D2, in this case 3D6. So it means 4s2 remains constant and 3D is getting filled up one by one. It keeps on changing. So as we move across the transition series, electrons are added in the n minus 1D. That is in this shell, n minus 1D shell. The electrons are getting added. The outermost shell remains constant. So the 4s2 remains constant. So this is constant, right? Now the d electrons filled poorly because we already seen that. See that we have discussed it here. The d electrons has poor shielding effects. Are you able to follow? Greater shielding effect, poor shielding effect of D. Okay. So in this case, the D orbitals have poor. Okay. It has got poor shielding effect. Okay. These D orbitals, right? So the D electrons shield poorly so that the effective nuclear charge increases steadily. So, what is effective nuclear charge? For instance, you've got 26 proton here. And what happens here? See, it starts influencing what? The all electrons here, and because of this poor shielding, it tries to attract the 4s2 electrons. And thereby, the effective nuclear charge increases steadily because you are going on increasing. So when it increases, what happens? The small decrease because it starts attracting. Okay. So it means the atomic size is getting reduced. Normally, what we expect with the increase of electrons, we expect the increase of atomic radius because what is atomic radius? You've got the center nucleus and the distance between the outermost electron and the innermost nucleus. This is the atomic radius. So, what we anticipate with the increase of atomic number, there is an increase in the atomic radius, but because of this poor shielding effect of this d orbital, the atomic size decreases across the series. So, this is called d block contraction. The size is getting reduced. So the atomic size, that is atomic radius, decreases slightly from scandium to copper. And the poor shielding electron of d electrons means the nuclear charge increases, the outer electrons are pulled inward more effectively, and that is responsible for the size reduction. Now let us talk about the F block elements. In the case of lanthanides and actinides, the electrons are added in the F orbital just like in the case of d orbital. So the F electrons shield outer electrons even more poorly than d electrons. So I hope now you can understand the shielding effect order can be, that is, this has very poor shielding effect. Okay, so the shielding effect, let us call it shielding effect, and this is worse in the case of F, and it is better in the case of D, and it is better in the case of P, and it is better in the case of S. Do you understand? So F electrons, F orbitals have poor shielding effect, d orbitals than d orbital. D orbitals have poor shielding effect than p and s, and p has less than s. It means s has the highest shielding effect. Okay, so um, because the orbitals are more diffused and buried inside. So why these f orbital electrons have very poor shielding effect than d electrons? Because their orbitals are more diffused, okay, more spread and buried inside, and that is why this prevention is weaker in the case of f electrons. So the result is significant contraction across the series, and that is why it's called lanthanide contraction, and the actinide contraction in the case of actinide. Okay, and when you look at the example here, that is in the lanthanide series, atomic radius decreases from lanthanum 3 plus to lutetium 3 plus. That is, it has got 106 picometer. Picometer means 106 into 10 power minus 12 meter. Whereas in the case of lutetium, it is 86 picometer. So the contraction explains why elements after lanthanides like 4 and D transition metals have almost a similar atomic radii. So the key points are either you can put it in the that is increasing order or the decreasing order like this. Okay, so this is the increasing order of shielding effect. This is the decreasing order of shielding effect. It means S has the highest screening effect and F has the lowest screening effect. So poor shielding effect in D and F causes higher effect in nuclear charge that results smaller atomic radius, and that is responsible for higher ionization enthalpy. So naturally, when the atomic radius reduces, it takes more effort to that is lose the electron or to become the ion, and that is why ionization enthalpy is higher here. Okay. Now let us look at the table here. Here is a comparative table regarding the screening effect. S block, P block, D block, F block. Electrons involved. In S block, S electrons outermost. P electrons are outermost electrons in P block. N minus 1 D electrons here. And F block, F N minus 2 electrons. So the shielding effect is, in the case of S, it is very strong. In P, it is strong but less than P. Less than S, it is poor and is much poor. That is F. And what about the effectiveness order? It is the highest, whereas S is greater than P, and here S is greater than P, that is greater, much greater than D, and here S and P are much greater than D and F, and F has the worst shielding effect because of the diffused one. So the outer electrons, what are the consequences? The outer electrons are shielded, well shielded, and that results the low, that is atomic and ionic sizes. Okay, in the case of S block it is more, and the effective nuclear charge is less in this case, whereas in the case of D block, here weak shielding and the attraction is more, the D block contraction is more, so it means there is an effective nuclear pull, and a high nuclear pull, nuclear charge results lanthanide and actinide contraction, and we have cited the examples. You can go through that. So the summary here is order of shielding effectiveness. S is much greater than P, P is much greater than D and F. So the poor shielding effect of D and F causes greater nuclear attraction, that is effective nuclear charge, that results smaller radii, and that results the lanthanide contraction or D block contraction. Okay. So here are the important that is the keywords here. Keywords: screening effect. Don't forget screening effect, shielding effect, effective nuclear charge. It is called as Z and effective. Poor shielding, D block contraction, F block contraction, lanthanide contraction, actinide contraction, atomic radius, ionization enthalpy, S electron that has got strong shielding effect, P electrons moderate shielding effect, D electrons weak shielding effect, F electrons very weak shielding effect. So the order of shielding S is greater than P is greater than D is greater than F. Inner shell electrons, outer shell electrons, transition metals or elements, then lanthanides, actinides. Okay. So these are the keywords you have to remember. And you please go through these questions, which should be very useful and it is shared in our topic call. Then